Hi, I'm Karan Singh, and today I'm here to share my work on autonomous drone delivery. So, back in January of 2021, I was selected by DPI to do some research on autonomous drone delivery alongside four different students from three different colleges and major. And I took the responsibility for doing software development and simulation. And this video is made to share my work on the same, at least what I think is presentable. So, let's jump right onto it. So, before we go any further, here's a quick disclaimer. Although the video is made to reflect my work on the research, there definitely are some overlaps on the work done by each team member. So the demo here today may include some contribution by other team members as well. Now since we have that out of the way, let's get started with the video. The last mile drone delivery cycle starts with a package loaded onto the drone. It takes off from the delivery van, goes to the desired address, drops the package, and returns to the delivery van. The van might be stationary or moving during takeoff or landing. I use technologies like ROS, Gazebo, RD Pilot, etc. to make a smart autonomous drone and test it. At the beginning of the research, neither me nor any of the team members had experience with it. And oh boy, they have a steep learning curve. Given the time and restriction and the learning curve involved, I decided to focus only on the basics of the autonomous drone rather than working on the logistics of delivery in this research. So what exactly did I work on? I worked on simple autonomous takeoff, going to the coordinate using GPS, landing accurately, and returning home. It is fairly simple to implement autonomous landing, but unfortunately, it is not accurate. Accuracy using GPS for landing is about 2 to 5 meters depending on the weather, which works for regular use of drone, but in our case, we needed an accuracy of 0.25 meters so that we could land on the delivery van and not crash onto the ground. Hence, to increase the accuracy, we added a camera at the bottom of the drone that calibrates its position while landing. To develop and test our solution for autonomous operations, I created a simulation where drone is taking off and landing on a 1 by 1 meter cube with a marker at the center. Due to wind and inaccuracy of GPS, drone falls off the cube without the camera assist, whereas the drone lands accurately when the camera is assisting the drone while landing. It is worth noting what the blue rays in the simulation represents. It represents a rangefinder which tells the drone how far it is from the area right below the drone so that it could land gently and turn off the motors after landing. Also, it makes the drone aware of the distance from land to maintain altitude. In the simulation, you can see 1 by 1 meter cube positioned in various locations and height. I created the sim world to test all the features discussed before at once rather than testing them individually. I've kept software in the loop for the simulation. That is, the same software stack is being used in simulation as it will in the real world. This helps us to do minimum work when we move to the actual drone. On the left, you can see the software running, and on the right, you can see the simulation running. Once the drone receives its mission, it arms, takes off, and moves to its first delivery address. The height of this point is lower than the initial point. You may notice a slight jerk on the drone right before it lands. I programmed it purposefully to demonstrate its capability to land accurately. Once the delivery is completed, it goes to the next delivery point, which is higher than both of the previous delivery points. I induce maximum jerk at this delivery point. Notice how well it finds the platform and lands gently. I ran the simulation 250 times, that is, 270 takeoffs, landing, and delivery points, out of which the drone missed once. Hence, getting an accuracy of 99.86% in its operations. And finally, it returns home, disarms, and waits for further delivery missions. So this is the minimum viable solution for autonomous drone delivery on simulation. Uh, the research came to an end before I could test the solution onto the real drone. But although I parted ways with DPI and the team in the month of May, I yet am planning to continue this project and make drone delivery into a reality. So please, if anyone who's interested into this project and would like to work with me to make to work on various drone delivery ideas or techniques, or just want to be on the team to make this a reality, just connect with me on karansinghcoacher.com. That is my website. There are many ways you can connect with me. You can drop me a message on various social media platform, or just drop me an email. You'll find the details right on the top of the website. So that being said, I am really thankful to the team and the DPI for this learning experience. I am really grateful to this opportunity, and I plan to make the most out of it. Furthermore, I would like to add that I'm currently, as I said, I'm continuing my work. So just stay in tune. I will be sharing my work on the research, which is going to be onto the real drone now, since the simulation is done. Although I'll be working on the features to add, but yeah, it's time to test on this boy. So, so I'd like to thank you all for sticking by to check this video out. If you like it, so great. If you don't, so sorry. I'll work better to make it. I'll work on it to make it better. But if you didn't like it, I can't do anything. So, anyways, guys. So, peace. We'll see you next time. And thank you for watching. Bye.